All right, and welcome everyone. So, at this point, we're going to leave the realm of geometric inequalities behind here. We're going to take a look at what's going on here. So we look at this object here. We have this thing ABCD, and, well, it appears to be a quadrilateral. That seems pretty fair, right? So let's take a look at what's going on here. We can try to figure out the value of x and everything else here. So I guess the first thing that I note, and this first thing maybe some of you may have noted as well, is the fact that we have these three angles in triangle ABD. So we know that those have to sum to 180 here. So I can write that 4x plus 2x minus 5 plus 35 is 180 here, right? We know that this is going to be a true statement like that. So we can use this to solve for x, right? So we get 6x minus 5 plus 35 is 180 here. So that gives us 6x plus 30 is 180. So you get 6x is 150, and therefore I think you get x is 25 here. Pretty straightforward, 25. Okay, so that's good, because now I can take the 25 and put everything into the picture here. So let's go back and fill everything in. So it's pretty clear that this is going to be 100 here, right? So I'll fill it in purple. I've got 2 times 25 minus 5. Well, double 25 is 50. 50 minus 5 is 45. So this is a 45 here. Okay. I have an x plus 10 here. So that's 25 plus 10, which is 35 here. That looks pretty good. And then we have 25 plus 20. That puts a 45 down here. That's good. And now note that triangle BDC here. That seems pretty fair. We got triangle BDC. We know 35 and 45 is 2 the angles. So the last angle has to be 180 minus their sum. So that's going to be 100 degrees here. Okay. So note here, let's take a look at what's going on. Okay, that seems pretty fair. Now, let's take a look at this object here, right? So this object, well, is there anything that we know about it just based on the angles? Let's see. I see two 35s here, right? I've got this 35 here, and I've got this 35 here, right? These two are both 35-degree angles. Now notice that both these angles are alternate interior angles here, right? I have an alternate interior angle with this and this here. So that guarantees us here with BD being the transversal. So notice that I have sort of that reverse Z thing here with here, AD and BC. So it seems like that in this situation, we're going to focus on AD and BC being parallel. So I can actually conclude this here, right? So this is going to be parallel to that. So now we have AD being parallel to BC here, okay? That seems pretty fair. Now, that's not the only pair of angles we see in the picture here. Not only do I have that pair of 100s, I also have that pair of 45s. And that pair of 45s is awesome because, as you can see here, these two, yet again, we have that Z-shaped thing going on here. So again, we have ourselves another pair of alternate interior angles that forces parallel lines, in this case, AB and DC. So we have this here, and now we also know that AB is parallel to DC as well, okay? So notice that this object, this quadrilateral here, ladies and gentlemen, has what we call here, this quadrilateral here, has two pairs of opposite parallel sides. And that's going to be really important to us because we can now use this as a definition here. So I think some of you are familiar with this object here. So we'll give it a name in a bit. But first off, I just want to mention here a couple things. So as I'm sure you are familiar with, but I want to make sure that we see it here, we mentioned this idea of a quadrilateral. It's a polygon that has 4 sides and 4 angles here. And that's going to be the subject of the next sort of 3 weeks worth of lessons, so to speak. But now, I think you've seen this before. We refer to this as what's known as a parallelogram. So we can mention here this parallelogram. Quadrilateral is a parallelogram if and only if it has 2 pairs of opposite parallel sides. And you can see here, this is our example. It's got 2 pairs of opposite parallel sides. That seems pretty good here. So we can say here, therefore, again, we'll leave it like this. A quadrilateral is a parallelogram if and only if it's got 2 pairs of opposite parallel sides. And that's the definition that we're going to be using here for the parallelogram.